Hello everyone, this is Mr. Sia, and today you will be learning about combinations of functions. Combinations of functions means you can add them, subtract them, multiply them, and divide them. Okay, but we're only going to focus on the first three today, so there will be no division of functions. We'll leave that for another lesson. So let's go ahead and get started. Okay, so before we go into the examples today, a quick review, okay, about quadratic trinomials and linear binomials. So this is called a quadratic because of the x to the second power, okay? And the shape of this graph, the shape of the graph of this function is a parabola, okay? So it's something that looks like this. And the shape of this one here, this is a linear because it's the first power, so the shape of this one is a line if you were to graph it. Trinomial because you see three terms. Binomial because you only see two terms. Okay, so let's go ahead and continue. Okay, so on this first example, all we're saying is that we are going to take the function f of x, okay, and we are going to add g of x to it. Okay, so this is what that means. So I'm looking at f of x. F of x is 3x squared, and I'm going to use parentheses, and you'll see why in a moment, especially on the second example. 3x squared minus 5x plus 4 plus g of x, that's 2x minus 3. Next, I'm going to remove the parentheses. Okay, so this will be 3x squared minus 5x plus 4. There's a 1 implied, but this one, since it's positive, is not going to affect anything inside of this parentheses. So then I'll just copy that as it is. Okay, and next I'm going to combine like terms. So 3x squared is going to be by itself. I don't have anything else to combine it with. And then negative 5x and positive 2x combined to, so this is negative 3x. And then positive 4 minus 3, that's going to be a negative 1. So then f plus g of x is equal to this. So this will be my answer for this problem. So that was an addition problem. Let's go on to a subtraction problem. And now you'll understand why we need to use parentheses and keep the parentheses, okay? So this is f of x minus g of x. So I'm going to subtract g of x from f of x. But f of x is our quadratic here. So this is 3x squared minus 5x plus 4 minus, we said g of x is 2x minus 3. Okay, and again, negative 1 implied in front of the parentheses. So I'm just going to remove parentheses for this one. And I'm also going to do it for this one, but I'm going to distribute that negative 1 to the 2x's. So this becomes negative 2x, and negative 1 times negative 3 is going to be positive 3. Next, I'm going to combine like terms. So just bring down the 3x's to the second power. Negative 5x minus 2x combined to negative 7x. And then positive 4 and positive 3 combined to positive 7. So then f minus g of x is equal to 3x squared minus 7x plus 7. Okay, let's go on to the next example. This one is a little bit different. I have a 2 in front of g, so that's what this means. 2 times g of x minus f of x, okay? So then I'm looking at the function g. It's this function. So then this is going to be equal to 2. Instead of g, it's going to be 2x minus 3 minus, instead of f of x, 3x squared minus 5x plus 4. Okay, so then again, a negative 1 implied. I'm going to distribute that 2 to the g function. So 2 times 2 is going to be 4x. 2 times negative 3, that's negative 6. Minus negative 1 times positive 3x squared is going to be negative 3x squared. Negative 1 times negative 5x, it's going to be positive 5x. Negative 1 times positive 4, negative 4. And I'm going to bring the highest exponent to the front. Okay, so that's going to be negative 3x squared. And then next I'm going to combine the the x's. So I have 4x and 5x. When I combine those two, they combine to positive 9x. And then negative 6 and negative 4 combine to negative 10. So 2 times g minus f of x is equal to negative 3x squared plus 9x minus 10. All right, so that's the examples for addition and subtraction. The rest, or the next two, are for multiplication. Okay, so on the following example, I'm going to multiply the function g by the function h. So this is going to be g of x. That means the product of g of x and h of x, which means I'm going to multiply the two functions. So I'm going to replace g of x with 2x minus 3. Okay, so this is 2x minus 3 times h of x is 3x plus 1. All right, now 2 times 3, that's going to be 6. And x times x is going to be x to the second. And 2x times positive 1 is plus 2x. And negative 3 times 3x is going to be negative 9x. And negative 3 times 1 is going to be negative 3. So then I'm going to again combine like terms. Just bring this 6x squared down. Just bring it down. And then this one here, positive 2x minus 9x is going to be negative 7x. And this negative 3 is by itself. So just that constant. So then we have that the product of g and h of x is equal to 6x squared minus 7 minus 7x minus 3. Okay, so let's go on to the next example. On this one here, again, I have the product of f and g. So f, it's a trinomial, a quadratic trinomial. So that's 3x squared minus 5x plus 4, and then g of x is 2x minus 3. Okay, so then constants, 2 times 3 is going to be 6, but x to the second times x to the first, that's going to be 6x cubed, or to the third. 3x squared times negative 3, that's going to be negative 9x squared. Next, negative 5x times 2x is going to be negative 10x to the second. Okay, negative 5 times negative 3, so negative 5x times negative 3 is going to be positive 15x. Next, we have the last term here on the trinomial. 4 times 2x is going to be plus 8x. And 4 times negative 3, that's going to be negative 12. And now I'm going to combine like terms so I can simplify this. So that's coming from here, 6x squared cubed. I can't combine this one with anything else here. And then I'm going to combine the x to the second power. So negative 9 and the negative 10 combine to negative 19x squared. And then I have 15x and positive 8x combined to 23x. And last I have negative 12, so minus 12. So in the end, the product of f and g of x is 6x cubed minus 19x plus 23x minus 12. Okay, now the next few examples, we are going to use values. Okay, so we are going to evaluate the functions and subtract one function from the other using values instead of variables. So all this means is that I'm going to take g, and wherever I see x on the g function, I'm going to substitute that x with a 3, and the same goes with the f function. I'm going to replace that x with a 3 value. Okay, so for this one, just to keep me organized, I'm going to use brackets, and you'll see why in a moment. Okay, so I don't get lost with the parentheses. So I'm looking for g of 3. So this is the g function here. So I have a 2 in front of the x, and instead of x, I'm going to replace that x or substitute that x with a 3. Minus, okay, so minus 3. So this is the g function. Now let's do the f function. The f function is, again, bracket 3 times 3 squared minus 5 times 3 plus 4. And I'm going to show all the work, okay? So this will be a long one to evaluate. So then 2 times 3 is going to be 6 minus 3 minus, so this is 3 squared is going to be 9, okay? Minus 5 times 3, that's 15, and plus 4. So then this is going to be 6 minus 3 is going to be 3. Minus 3 times 9 is 27. Okay. So then this is going to be 27 minus 15 plus 4. So then this is equal to 27 plus 4 is 31. 31 minus 15. That's 16, so 3 minus 16. So in the end, the answer is 3 minus 16 is negative 13. So g minus f of 3 is equal to negative 13. Okay, on the next example, I might run out of space, and this was my mistake. Okay, so I apologize. If I do that, I might get all the way to here. So just be ready for it, okay? So this one is a fraction. So we have g plus h of 1/3. And all that means is that I'm going to evaluate the function g when x is 3. And I'm going to evaluate the function h when x is 1/3, I'm sorry. And then add them together, okay? So I'm going to replace, instead of g is parentheses 2 times 1/3 minus 3. And then plus h is 3x plus 1. So 3 times 1/3 plus 1. Okay, so this equals 2 times 1/3 is 2/3 minus 3. And then plus, this is 3 over 1. So this is going to become a 1. This will become a 1. And it's 1 over 1. So in the end, we have 1 plus 1. Okay? Now, on this one, I need a 3, and it has a 1. So that means I need to multiply numerator and denominator by 3. So when we do that, so this is 2/3 minus 9/3 plus 2. 2 minus 9, so this is going to be negative 7/3. And I can just remove the brackets now. Okay, you'll see why in a moment. Okay, so negative 7/3 plus 2. And again, we have a 1 implied under that 2, so we need to get a 3 below this one. So then I'm going to multiply numerator and denominator by 3. So then this is going to be negative 7/3 plus 6/3. And since I'm running out of space, I'm going to bring this one all the way down here. So then I have g plus h of 1/3 is equal to negative 7 plus 6 is going to be negative 1 and negative 1/3. So this is the value for the combination of these two functions when x is equal to 3 on both functions. Okay, so let's go on to the next and last two examples. Very similar, but instead of variables, now we have a table of values. Okay, so all this is saying is, okay, so let's evaluate these two functions. Let's add them together when x is equal to 2. So this will be f of 2 plus g of 2. But now we have a table. So I'm looking at where x is equal to 2 on the table for f of x. So when x is 2, y is 5. Okay? And on g when x is 2, this is the function g, when x is 2, y is 7. So then I just add and tell you that when I add f and g, when x is equal to 2 on both functions, I just add 5 plus 7, which is 12. And this is the answer to that example. All right, so let's go to the last example here. So this just means g of 3 minus f of 3. So I'm looking at the tables again. All right, so g is when x is 3, y is 8. Okay, that's coming from here, minus f of 3. Now I look at the table for f of x. When x is 3, y is 6. So 8 minus 6. And 8 minus 6 is 2, which means that g minus f of 3 is equal to 2. All right. Thank you for watching. I'll talk to you soon. Bye-bye.